Now that we've studied the use of find in a little more detail in the driver, let's talk about field projection. This small application is an example of using projection in the driver. Now, as a reminder, the idea behind field projection is that in some circumstances, many in fact, we only care about some of the fields in the documents returned. Here, we are querying the companies collection for biotech firms once again, as you can see from our query object and the call to find here. I've added a projection document here so that the only fields we get back from our query are those we need for the message we are printing below. In a real application, you would project out just the fields you needed for whatever web page you need to display, an analytics task that you need to run, or some other job your application is designed to accomplish. Remember that projection allows us to explicitly include or exclude fields. We use a 1 to indicate that we want to include a field, and 0 to exclude fields. Again, remember that _ID is special in that it is always included unless we explicitly exclude it. All other fields are excluded unless we explicitly include them. Something else I want to point out here is that because we're working in JavaScript, we can construct our projection documents and documents to be inserted into our collections in a way that is very similar to the way we do this in the Mongo shell. What's different is that the driver provides one set of classes and methods we use to interact with MongoDB, and the Mongo shell provides its own API. With respect to CRUD, as of MongoDB 3.2, the Mongo shell and the MongoDB drivers adhere to the same CRUD spec. They support the same set of CRUD methods, including find one, insert many, and so on. How you access these methods and how they are implemented varies, of course, from the Mongo shell to the Node.js driver, and from the Node.js driver to drivers for other programming languages. We see one difference between the shell and the Node.js driver in the way we express projection. The current best practice in the Node.js driver is to chain a call to project onto our cursor. This call to project sets a field projection for the query. This call does not force a request to retrieve documents from the database, as does the for-each method. Rather, it adds some additional detail to the query representation maintained by our cursor. As we discussed in other lessons, there are a number of cursor methods we can chain together to fully express the operation we wish to execute against our MongoDB database. So let's quickly take a look at how this simple application is implemented. So here I'm creating a document for our query and a document for our projection. More precisely, we would describe these as JavaScript objects, but I'll use the term document and object more or less interchangeably as I discussed the Node.js driver. Then we have our call to find here, and this call will be synchronous. It won't actually go and fetch documents from the database, rather it'll simply immediately return a cursor to us. We're going to modify that cursor with a field projection here using the project method on cursors. And then we're going to call for each on this cursor, passing it this callback for iteration through the returned documents, and this callback as the second parameter to for each as a set of operations to run once we've exhausted the cursor, or if we encounter an error. Now, what I'm doing here is printing out the same message that we saw before, and what will happen is we'll see that all of our companies print out as a biotech company. But I've also added this log statement here to show exactly what the document is each time this callback is called. The idea here is that I want to demonstrate that this field projection is actually having the desired effect. So now let's run this. And we can see that, sure enough, we get a message for each document returned. But more importantly here, we can see that the structure of each document returned by this query is such that we only have the name and the category code. Going back to our application code, you can see that our projection stipulates exactly that. We want to include name and category code and exclude _ID. Now, so far in this lesson and others, when we've talked about projection, we've really only talked about it from the perspective of what we see inside our application. What's important to realize is that there is a performance advantage in that we're only sending over the wire and using network bandwidth for data that we actually need. This is a factor that can have a sizable performance impact, especially when there are thousands of clients making requests to our database. So imagine thousands of these guys making requests to our database system, and all doing so simultaneously. By projecting out just the fields we need, responses will require less time to assemble on the database side, less time to transmit to clients, and less time to process within those clients.